Hi students, welcome to the next topic from rotational motion. So far we have discussed about various topics including moment of inertia, various theorems, kinetic energy and so and so. So we are going to discuss about the another important topic, and which is as a subtopic, or it's a continuation of angular momentum, and which is called conservation of angular momentum. So please write down the heading called conservation of angular momentum. Conservation of angular momentum. Conservation of angular momentum. Okay, so this is a heading for today, conservation of angular momentum. We'll describe more about this one. So in laws of motion chapter, we are learned about Newton's second law of motion. What is Newton's second law of motion? It states that F is equal to dp by dt, rate of change of momentum is equal to force. So similar to this one, we have an analogous equation in rotational motion. F is replaced with torque, momentum is replaced with angular momentum. So dl by dt. This is called torque is equal to rate of change of angular momentum. Important. This relation is an important relation. So what happen if P is constant here? P is constant means P is not changing, force equal to 0. We can say initial momentum is equal to final momentum. P is not changing means momentum before an incident is equal to momentum after an incident, and the momentum is not changing. So that case we can write like this: Pi equal to Pf. Same analogous can be applied will be here. If L is constant, we can say torque equal to 0. So in conservation of angular momentum cases, there is no turning effects. And it is constant. So initial angular momentum is equal to final angular momentum. One way. So these are analogous to this one. So this is one set of equation. Another set of equations we can say I1 omega 1. I1 omega 1 is the initial angular momentum, and which is equal to I2 omega 2, and this is the final angular momentum. If you have multiple terms, maybe I1 omega 1 plus I2 omega 2 left side, right side I2 omega 3 plus I4 omega 4, like that it may comes, depends upon the question. But in short, if there is one momentum, then I1 omega 1 equal to I2 omega 2. Here how we will write? Here we will already write m1 u1 equal to m1 v1, initial velocity, and this is the final velocity. Okay, so this is an analogous to this one, which means whenever there is no force or acting on a body, the momentum is constant, which indicate force equal to 0. Momentum is constant, momentum is conserved. Same case is applicable for a torque also. When torque is equal to 0, which means angular momentum is constant. Okay, so let's have a problem. We'll do some numericals based on the concepts. Okay, then we'll move to the further topics. So this is quite simple, and there is no complications, but we have to apply in the numericals. We should know how we are applying in the numericals. So let's have a questions over here. Questions, please write down the question. A driver with moment of inertia, with mi, moment of inertia, 6 kilogram meter square, has omega is equal to 2 radians per second. He folds his body, means by within bracket hands in a folding, and reduces the moment of inertia, to 5 kilogram meter square. Find the new angular speed. First, what is the case which is happening over will be here. First, the driver whose moment of inertia is 6 kilogram and has a 2 radians per second, which means a driver is standing, and he is rotating with its moment of inertia. Moment of inertia is corresponding to mass in linear motion. That information I have given in the previous lecture series. So we have a moment of inertia and he is rotating with a speed of 2 kilogram, 2 radians per second. Then he folds his hands like this. Any external forces are applying? No. Is a man, he is simply rotating with an angular speed of 2 radian per second. After some time he folds his hands. So this is a best example for an conservation of angular momentum. Initial angular momentum is equal to final angular momentum. I1 omega 1 equal to I2 omega 2. I1 is 6 and omega is 2 is equal to I2. Further moment of inertia is reduced to 5. And what will be the new value of omega 2? Omega 2 has to find out. Omega 2 is equal to 12 divided by 5 radians per second. What is the beauty you can see over will be here? I omega is constant means I can say I omega is constant. So I is proportional to constant divided by omega, I can say, or I is equal to constant by omega, or I can say I is proportional to 1 by omega. Now you see will be here I is equal to 6, omega is equal to 2. Now I is reduced. 6 and 5 will reduce. So if I is reduced, then what will happen? Omega should increase. See, omega should increase because I reduce omega increase because it is inverse relation. I in the 6 and the 5 I. So omega is increase. 2 will in how much it will come? 12 by 5 means 2 point something, 2.4. Okay, so omega is increased to 12 by 5. 12 by 5 means 2.4. That is 2 will in the 2.4 lot omega increased. Remember that point. I is proportional to that value. Okay. So fine. We'll go with the next question. So let's clean the boat and then we'll go with the next question, next problem. Okay. You have to write these questions on your notebook. Okay. Fine. Okay. So let's have my next questions with me. So please write the question. A boy is standing on a platform. A boy is standing on a platform which is free, which is free to rotate, about an axis passing through the center. About an axis passing through center. The kinetic energy of the platform, the kinetic energy of the body and platform, is K. If the body stretches his hand, his hands and double the moment of inertia, double. Find the new kinetic energy. So first it is given a boy is standing on a platform and which is free to rotate with about an axis passing through the center. Its kinetic energy. So let's answer this. Kinetic energy is equal to with respect to I omega square. This is the relations with respect to moment of inertia. Now the new kinetic energy K dash is equal to what will happen? Now he stretches his hands and double the moment of inertia. Double I. So 1 by 2 into moment of inertia become 2I. If moment of inertia is double according to conservation of energy, here there is no external torque or there is no external force. So now he stretches his hands to make the moment of inertia to become double. Then omega will become half. Omega by 2 the whole square. So what will get? 1 by 2 ഇവിടെ I ഇവിടെ ഒമേഗ സ്ക്വയർ. സോ I ഒമേഗ സ്ക്വയർ. ഇവിടെ 2 ഇവിടെ 1/4. ഇവിടെ 1/4 2 വരും, ക്യാൻസൽ. സോ ബാലൻസ് 1/2. I can say the new kinetic energy is equal to K dash, which is equal to K/2. This is an important question. Okay, remember that it's an important question. Okay, fine. So conservation of angular momentum is important. Okay, based on this hand stretching kind of questions may ask. Okay, so remember, okay, if somebody is not applying any forces, then it stay as it is. Fine. So let's move to the last topic of the rotational motion series video. So the last topic is the rolling motion. So please write on the heading called rolling motion. Very much tricky questions are coming from this area. Concept is simple if you understand correctly. Okay, so listen to the board. There are always, you know, like in Neet paper as well as IIT paper, engineering papers, any paper, there are some category of difficult questions will be there. So always students will commit mistakes or students will leave the question, especially from the topic of rolling motion, because many steps are involved in this one. Okay, so this topic is very important, definitely looking to score a very high mark for engineering as well as for medicine. Okay, what is actually called a rolling motion? A rolling motion is actually, you can remember, just like a ball is rolling, right? A ball is rolling. So this is a ball and which is rolling. Rolling motion is equal to, I am writing, translatory motion. Translatory motion means linear motion plus rotational motion. Rotational motion. Okay, you can imagine you are throwing a ball to the floor and the ball is rolling. Rolling as well in the sense, rolling means rotation, it is rotating. At the same time it is moving forward. So that forward motion is called translatory, and that rotating and that turning effects, which is called rotation. So that translatory, the the forward pull and the rotation, so these two together is called rolling. So rolling motions, I can say a linear velocity is involved in this one, linear velocity, and as well as in a simple way an omega, an angular speed involved in this one. So always a rolling motion involves two parameters in terms of velocity, acceleration. In terms of acceleration also there are some other parameters, but we'll start with velocity. So two parameters are involved, one is the velocity and one is the omega. So this velocity is called the velocity of the center of mass. Center of mass. If this is a ball, then a ball in the center line in the velocity act in, that is a linear velocity, and that is we have written as VCOM, velocity of the center of mass. So in a rolling motion, for velocity there are two parameters are involved, one is velocity of the center of mass and omega. Next, what we are going to do means we are going to find out the velocity at different positions, of a body. Okay, so you can write the subheading under the rolling motion, net velocity in a rolling motion. Net velocity in rolling motion. Rolling motions net velocity. Listen to the board very clearly. Okay, suppose this is a circular motion. So earlier case this is a full ball, so center of mass will be here. Now I am assuming I have a ball will be here. This is the ball now. Okay, this is a ball now. So previously this full stuff is a ball. This full stuff, so this is a ball initially which is available over here and which will be occupied with what called, which will be occupied with the center of mass. Now this is a ball the same way. So when it is at the top, there is a center of mass. So VCOM velocity will be here, and because of this omega is called the actually it is called the turning effects, right? Because of the turning effect. So V is equal to, I already told you one equation, Vt is equal to R omega. So Vt is a tangential. Vt is a tangential. Vt is equal to omega cross R. Omega cross R. So this direction of this omega at this point will act a tangential velocity component, and which is called R omega. So R omega is Vt. So there are two velocities will be there. Omega will give rise to a velocity called Vt, and Vt is equal to R omega, and that is a tangential velocity at this point. So two velocities will be there in the same direction. Instead of marking over here, I will mark like this. So this is called Vt, which is equal to R omega. So two velocity. So in this case, what is the formula for net velocity? Net velocity means it's a two velocities which are in the same direction. So Vcom plus R omega. I can write this equation. Clear? Pakka. Next one, in the next stage, in the same circular motion, but if the body is located at this point, so what is the velocity? Center of mass, anyway this is moving forward, so center of mass direction is always in forward, because this is given by translatory motion. Now we have a rotational motion component. Rotational motion means omega. Omega will give rise to tangential. Now the motion of the body is like this. Now the motion of the body is like, so there is a tangent because it is rotating like this. This is called R omega. So how to find out the resultant of the two vector which is making 90 degree? So this is our V net. So what is the V net will come? So you know, now our V net equal to how will say root of Vcom square plus R omega the whole square. Next case, when the bob is or the particle is at the bottom position, still we are moving forward. Okay, so our motion will be forward, so there is a Vcom, but there is a tangential velocity R omega in this direction. So if it is completely rotating each and every point, there is a tangential velocity, tangential like this, tangential like this, tangential like this, tangential like this. This is our Vt, this is our Vt, this is our Vt, this is our Vt, tangential, rotating like this. Opposite opposite. Okay, so here, so how what we can say for V net equal to Vcom minus R omega. Okay, whatever is higher value minus lower value you can do. And the final one, if the body will be rotated over here and it is rotating like this one omega, so this is called Vt and which is R omega, but center of mass, but the Vcom still there. Vcom is always pointing the direction of the translatory motion. The body is moving forward, and we know this is our V net. Okay, so in this case, what is V net? Net velocity is what? Root of Vcom square plus R omega the whole square. Vcom plus R omega the whole square. So you can see the second one and the fourth one are same, exactly one and the same. So these four cases are important to remember. Okay. So we'll do one questions out of this based on the things. We will do one question and we'll see what is coming over here. Okay, so hope this is clear. At 4 positions the things are given. Okay, next one, this is there on your books also, all standard books. If you refer, you can see. Okay, now we will do another things which is similar to this one. Okay, next we'll see, right? Special case, write an heading called special case. Very special case. We are going to see a special case. We are going to see a special case. What is that special case indicate? Body will be like this, and from the center this is makes an angle theta. A body which is located over here at an angle theta, it's not at the bottom, it's not at the bottom, it's not at the left, not at the top, not at the bottom, but it makes some angle theta. This will give you some general expressions for you, right? So how we will split the components accordingly? Here we have VCOM and we have a tangent like this, VCOM, and this is R omega. So what we have to do, we know if this angle is theta, of course, if you know this angle is theta, what is this angle will come? 90. What is this angle come? 90 minus theta. 90 minus theta. And we want to know what is about this angle. This angle also we want to know, right? So based on this only you can see. Now you can see this is a tangent to the radius. So the radius and tangents makes how much degree? Always 90 degree. You see over here, this is a tangent. So radius makes 90 degree. This is a tangent. This is a radius 90 degree. So now here at this point, this is a tangent. This is a radius 90 degree. So everywhere tangent with the radius makes 90 degree. So this is a radius line and this is an R line, and with R omega it's a tangent line makes 90 degree. Okay, now this looks like we have a two vector, one is VCOM and one another is R omega. The angle between them, total angle is how much? 90 plus 90 minus theta, 180 minus theta. So we'll find the net velocity. So V net equal to, what is the general formula? A square plus B square plus 2AB cos theta, if A and B are vectors. Then what are the two vectors will be here? VCOM square plus VCOM square plus, okay, R omega the whole square plus 2 into VCOM R omega into cos of 180 minus theta. This is the general expression. There is one question will be there for the previous engineering entrance examination, and what is that is given over will be here. The only end will be V's. Okay, we can write if VCOM equal to R omega equal to V, then how this will changes? Root of V square plus 2V square cos of 180 minus theta. What is cos of 180 minus theta? We know all sin t coffee. So 180 minus theta means second quadrant. Second quadrant sin the reverse of cosec is positive. So cos is negative in the second quadrant. So this will come root of V square plus 2V square. Cos of 180 minus theta means minus cos theta. Okay. So what we can do? 2V square, we will take it 2V square outside. So root of 2V square into 1 minus cos theta. 1 minus cos theta. What is the trigonometric formula for 1 minus cos theta? What is 1 minus cos theta? 1 minus cos 2 theta is 2 sin square theta. So this value will become root of 2V square into 1 minus cos theta means 2 sin square theta by 2. This trigonometry and trigonometry standard formulas definite item. Okay, in case you don't know, please have a look into your 11th or 12th mathematics. Illana, the second option is just to Google it, the basic formulas from trigonometry, and such kind of formula you have to remember, else you will block at some point, maybe at least for 1 or 2 questions. So please take care. So 2 and 2 become 4. So 4V square verma 2V sin theta by 2 is the answer. This is an JE main questions where VCOM and all are given as the same values. Okay, fine. So let's do another question and see what is coming to us. Okay. So two velocity component, we have to mark it accordingly. That's all. That is the pulse of the question, pulse of the topic. So questions can ask in any way, but yeah, you have to able to mark the direction of the center of mass of velocity component as well as the tangential velocity of this one. Okay. So next question. if a body is rotating as shown in figure, the velocity at POQ are VP, VO and VQ. VP, VO and VQ. So a diagram will be given. This is P, central O, E point Q. Okay. Which of the following is true? Which of the following is true? So there are some options which are given to you and you want to find out which of the following is the right answer. This line line this positions. 4 options are given to you. VP is equal to VO is equal to VQ. VP greater than VO greater than VQ. VP less than VO less than VQ. VP greater than VO. VP greater than VO. VP greater than VO, which is equal to VQ. Which is equal to VQ. Okay, not like this. And VP greater than V0, sorry, and VQ greater than V0. VP greater than V0. illa 4 options ide mai varade. 1 second. VP equal to V0, VP greater than V0, all are less. Okay, and okay, got it. VP is equal to 0 and VO equal to VQ, like this. Sorry, 1 second. VP is equal to VQ, VP is equal to VQ and V0 equal to 0. Okay, like this. Okay, so 4 options we have. VP all are equal. VP greater than V0 greater than VQ, VP less than V0 less than VQ, and VO center is equal to 0 and VP is equal to VQ. Tell me what's the answer for this one. What we have to do? Tell me, boys and girls, what we have to do? Here we have a center of mass. Okay, VCOM. So the body is rotating like this, which is given in the question. I forgot to mark this arrow mark. So once it is rotating, we want to mark a tangent. Tangent perpendicular ആയി വരാതെ. ഇപ്പം what you can do means ഈ ഒരു P point വരുമ്പോൾ we can assume it's like a circle like this. So ഇതേമാതിരി വരുമ്പോൾ ഇതാണ് ഇതിൻ്റെ ടാൻജൻറ്റ് വരുന്നത് r omega. അപ്പോൾ ഇതിനൊരു vertical axis we can consider. This is just our consideration only. Okay, so all വരുമ്പോൾ center point ഇപ്പം suppose if you are looking to your fan അതിൻ്റെ സെൻറ്റർ പോയിന്റ് എക്സാക്ട്ലി ആ സെൻറ്ററിൽ ഇരിക്കുന്ന പോയിന്റ് ഇറ്റ്സ് നോട്ട് റൊട്ടേറ്റിംഗ്, അത് റെസ്റ്റിലായിരിക്കും. സോ സെൻറ്ററിൽ വരുമ്പോൾ r omega equal to 0. Only what is will be there? VCOM will be there only at the center. ഇനി ഈ പോയിന്റിലോട്ട് വരുമ്പോൾ body is moving like this. So VCOM will be here and we have a tangent of r omega. Okay, now this will make this a 2 component, horizontal component and vertical component. This also we can split it as horizontal and vertical. Okay, now listen to the board very carefully. Now here this vertical I am considering an angle called theta. Appo ee oru angle what will be? This is called theta. ഈ ഒരു ആംഗിളും തീറ്റ ആയിരിക്കും, കാരണം ഇത് സിമെട്രിക്കലാണ്, ഒരേ ലൈനിലാണ് POQ, ഒരേ ലൈൻ ഇറ്റ് ഈസ് കമ്മിങ്. സോ ദിസ് ക്യാൻ ബി റിട്ടൺ ആസ് r omega cos theta and another factor is r omega sin theta. r omega സ്പ്ലിറ്റ് ചെയ്തു. ഇനി ഈ ഫാക്ടറിലോട്ട് പോകുമ്പോൾ what will come? r omega cos theta and this will become r omega sin theta. ഇനി if you look into the point P, okay, if you look into this point P, ഇതാണ് P. ഈ P യിലുണ്ടാകുന്ന ഈ പി എന്ന് പറഞ്ഞ പോയിന്റിലുള്ള ഒരു ഫാക്ടർ, ഈ ഫാക്ടർ ഇതാണ് പിയിലുണ്ടാകുന്ന നെറ്റ് വെലോസിറ്റി. ദാറ്റ് ഈസ് എ വെർട്ടിക്കൽ വെലോസിറ്റി ആൾസോ ദർ. ഇറ്റ്സ് അണ്ടർസ്റ്റുഡ്. ബട്ട് ഹിയർ ഐ ക്യാൻ സേ, okay, here I can say velocity at the point P v com plus r omega sin theta in this direction. Here there is a vertical component of velocity, I agree, but the block is not moving in this direction, right? Block is moving in this direction. So I am interested about this horizontal component. So that's clear. So what is at the center? I told the center there is no rotations, only translatory motions. So I can say v com equal to vo. Okay, now at this point, ഈ പോയിന്റ് എടുക്കുമ്പോൾ upward force r omega cos theta, but that is important. Block is not moving upward, the body is moving in this direction. So what is velocity will be here? v com ഈ ഒരു ഡയറക്ഷൻ r omega sin theta opposite direction. So r omega sin theta which is equal to vq. From this one, what is the right answer? Vp is the highest value, Vo is the second value, Vq is the lowest value. Answer is option B. Option B is the right answer. Okay, important aanu. This model of questions are important. Hope this is clear, right? Why we are considering horizontal component? Because the motion is horizontal. Motion is not up and down, not vertical. So this factor has no role. He will be here to deciding the value of Vp and Vp. If you consider same component here and same component here as well, but it has no meaning because it's a rolling motion in the horizontal direction. Let's move to the next topic. Now this is all about the velocity in a rolling motion. We are going to see acceleration in rolling motion. How many accelerations are available in a rolling motion? Okay, how many velocities are available in rolling motion? Two velocity. What are the two velocity? Vcom and Vt. Vt means tangential velocity, which is equal to r omega. Okay, but how many accelerations are involved will be here? Acceleration in rolling motion. Previously it is velocity in rolling motion. I don't know I have written the heading or not. I didn't remember now. In case if it is not written, please write velocity in rolling motion for the previous topic as a heading. Here acceleration. How many velocity we have? Tell me how many velocity we have here? Two velocities, right? How many acceleration we'll have? Sir, two acceleration. Wrong. Khatam ho gaya. It's wrong answer. There is not two acceleration. There are three terms. Listen over here. Suppose the body will be at this point. Okay. There is one acceleration which is called a tangential acceleration. At is equal to r alpha. R alpha we already learned. At is equal to r alpha. Okay. Then we have a centripetal accelerations. AC we have. So we have centripetal acceleration, AC will have, and the body will have one center of mass will have one acceleration which is called ACOM. So how many accelerations are? Three acceleration, ACOM, AT. Similar to this one, VCOM and VT, but this guy is extra, AC. Centripetal acceleration. When the body started to rotate, what is the value of centripetal acceleration? 0. I told, right? Centripetal, when the body started to rotate, the omega value, AC is equal to V square by R, which is equal to R omega square. When the body started to rotate, omega will become 0, AC will become equal to 0. Okay, so this is a point. Now depends upon that we have to find out the value of accelerations at a different point. That is a whole story behind this one. Okay, so we have to calculate the velocity at a different point. So only these are the things will be given. Let me draw one diagram over. Will be here at this point. If the ball will be at this point, what all the things will be here? You will say, sir, I have ACOM because the motion is like this, rotation is like this. Correct. Then what is extra will be here? Extra will be here a centripetal acceleration AC. Sir, we have one more acceleration which is called tangential acceleration AT. Correct. Okay, so now we have how many velocity components we have? We have two velocity component and 3 acceleration component. How we will find the net acceleration, sir? Sir, I know net acceleration is equal to root of either into array direction, so ACOM plus AT other together whole square plus the other term called AC square. Very good, sir, very good. Okay, this was the idea behind this one and you have to apply. So here two things we want to know. This AC here, AC will be is equal to R omega square and AT will be equal to R alpha, and this is equal to V square by R as well. Okay, this formula you have to remember. We will use depends upon the questions. Okay, now I will ask you one more questions to you. Suppose the ball will be here, we are rotating like this. What is this? Is called ACOM. Next one AT, tangential accelerations are where the tangential accelerations will go, in what direction the tangential body is rotating in this direction. So tangential acceleration is like this, and sir you have AC like this. Correct, sir. Okay, now how you will find the resultant of these two things? Previously we don't have AC. In case of velocity we have VCOM and VT opposite direction. So what we done? VCOM minus VT we done 5 minutes before. Story is different now. So how to find out this one? This can be drawn as, I can have ACOM in this direction and AT e side minus out, so minus AT in this direction, and I have AC in this direction. So this is my net acceleration. How to find out the net acceleration? Now you know A net equal to root of ACOM minus AT the whole square plus AC square, centripetal acceleration. Okay, so at any point whether it is here, this you can try. When it is will be here, ACOM in this direction, AT is in this direction, AC is in this direction. So you have to calculate it accordingly. Okay, so I'll just draw left lum, right lum ACOM in their direction level. So centripetal acceleration AC in this direction, tangential acceleration AT. Again AC in our side, so ACOM minus AC and AT is downward. So you can add, you have to take a root of. So how will come? We for this case the net acceleration, how I can do idine e side lote replace him. So I can draw the diagram with ACOM പിന്നെ ഇതേ ഡയറക്ഷനിൽ മൈനസ് AC പിന്നെ AT ഡൗൺവേർഡ് വരുമ്പോൾ ഇത് രണ്ടും we can add. Now both are in the same direction. So how to find out the net acceleration? A net, how it will be? Root of, tell me, ACOM minus AC the whole square plus ഇതെല്ലാം റൂട്ടിലാണ് plus what will come? AT square. ACOM minus AC square ബോർഡിൻ്റെ ബോർഡർ ആണ്, അതുകൊണ്ടാണ് I am repeating again. ACOM minus AC square plus AT square. ഇത് ലെഫ്റ്റിലാണ്. Same way you can calculate it at the rightmost position, leftmost position also. What will come in the leftmost positions, I will tell you that also, so that it will be pakka clear, right? Fine. So I'll tell you one more point. So when the body is at this point, this is called ACOM and this is called AC, and the body is rotating like this, so this is called AT. So A net will be equal to, both are in the same direction, so ACOM plus AT the whole square plus AT square. So this is the answer, correct answer. Okay, here it is ACOM plus AC, both are in the same direction, plus AT square. Simple line. It's quite simple, right? Akka. Fine. Next heading, I need some space. Okay, next one we are going to see about kinetic energy and momentum of a rolling motion. Momentum. Okay, so let's start with the momentum is angular momentum and linear momentum will be there, but we'll start with the kinetic energy of rolling motion. Okay, so please write the heading, kinetic energy of a rolling motion, kinetic energy of rolling motion, the kinetic energy. Rolling motion, the kinetic energy means I can say kinetic energy of rolling equal to kinetic energy of translatory plus kinetic energy of rotation. Okay, so kinetic energy of rolling again is equal to kinetic energy of rotation half mv square, kinetic energy of translatory normal kinetic energy half mv square, and kinetic energy of rotation is half I omega square. Okay, kinetic energy of rotation many equations under. Kinetic energy of rotation is equal to half I omega square. This is one equation. You know L is equal to I omega. So this can be written as 1 by 2 L omega. Second equation. Next equation is L square by 2 I. Correct? I square omega square. I cancel. So three set of equations are there for kinetic energy of rotation. This is equations. If you simplify, everything will come to this point. If L square I square omega square. I square omega. So I cancel out. So I omega, half I omega square will come. So kinetic energy of rotations will have three set of equations over will be here. Here V in this is a linear motion. So linear motion is contributing to not R omega. It's a translatory motion. So V will be equal to R omega here. So remember that as well. Okay. Fine. Good. So let's do one question. Then yes, first we'll do one question, then we'll go to the next topic. We have some key points are coming. Okay. I'm thinking about the order, how it should go. So the questions we'll do and then we'll see. Okay, fine, perfect. So question will be, find the angular speed of the bob when it reaches at the bottom. When it reaches at the bottom. We have a diagram like this and it's falling down. So yeah, this is for a height of h. Find the angular speed of the ring moment of inertia we can consider. Find the angular speed of the ring when it is reaches at the bottom. Okay, so what we have to do this kind of question. So initially we'll be here at rest, then it is starting. So we'll apply total energy at initial point equal to total energy at final point. When it is standing will be here, which will have potential energy plus, so what will do? Potential energy plus kinetic energy is equal to potential energy initial, kinetic energy initial, potential energy final, kinetic energy final. So kinetic energy initial 0 because the body is not rotating, body is not moving. Okay, so we'll substitute for this values. Potential energy at the highest point mgh is equal to potential energy at the downside when it is coming down, when it is reaches at the bottom, there is no height, so potential energy is 0. Okay, so let me make it one more step. This is 0 is equal to, and potential energy, this is 0 and this is 0 and this is this one. Kinetic energy, it's rolling. Okay, find the angular speed of the ring when it reaches at the bottom. This is you can put it like an omega, so this indicates a rolling motion. Okay, so half into mv square plus half into I omega square, this is the kinetic energy of rotations. So mgh, okay, so mgh equal to half into m into ഇതിന് r square omega square we can write 1/2 moment of inertia of a ring. ഇത് റിംഗ് ആണ്, റിംഗിന്റെ moment of inertia is mr square omega square. So what will come? Half mr square omega square, half mr square omega square. So which become mgh will be equal to mr square omega square. M cancels. We want to find out mr square omega square. We want to find out omega. Omega is equal to, what will come? Root gh divided by r. Root gh divided by r is the value of the angular momentums. Okay, fine. Okay, so let's go to attend some key points. We have some key points will be here, so you can just make a note of some points. We are going to write some few bullet points based on some conditions. Okay, or yeah, we'll split as small headings. Okay, we'll write some special cases. Special cases important ആണ്. Special cases. Number 1, velocity of the body with respect to ground in pure rolling motion. What this indicates is that if a body, listen very perfectly, listen very clearly, this is called r omega when the body, okay, in a pure rolling motions, suppose this is a body which will be here and will have a vcom. In pure rolling motions, the velocity with respect to ground, the velocity with respect to ground, ഈ ഗ്രൗണ്ടിൽ ടച്ച് ചെയ്യുന്ന ആ പോയിന്റിൽ velocity should be 0. That should not be no velocity to have a rolling motion. So for rolling motion, so velocity of the body with respect to ground in pure rolling motion, and what is the value of this one? And this velocity, so you can say this velocity at the bottom point, at the bottom point, this velocity at the bottom point is equal to 0, which means vcom minus r omega is equal to 0. Omega is equal to vcom divided by r. This with respect to ground. This is with respect to ground. Okay, so we can also say the velocity, we can, from this one we know vcom is equal to r omega, both should be same, then only rolling motions will happen. Okay, so this is the conditions for a rolling motion. This is the conditions for a pure rolling motion. 100% this is a rolling motion, but there are some cases maybe you can expect. For example, if vcom, our velocity, if it is greater than r omega, then it is an example of a forward slipping. There is no rolling, it's like a sliding, skidding ആണ്, velocity higher ആയിരുന്ന. In another way I can say r omega greater than vcom, so r omega ഈ സൈഡിലോട്ട്, then it's a backward slipping. Then it's a backward slipping. Slipping ആയിരിക്കും, forward ആയിരിക്കില്ല. To have a rolling motion, both velocities should be equal to one with another. Okay, fine. So velocity of the body with respect to ground in a pure rolling motion. First special case over ആണ്. We are going to the second special case. We are going to the second special cases. ഇതെല്ലാം ക്വസ്റ്റ്യൻ ആണ്, ആക്ച്വലി റെഡി മെയ്ഡ് ക്വസ്റ്റ്യൻ. ഓക്കെ, വാട്ട് എവർ ഐ എം ടെല്ലിങ് ഇസ് എ റെഡി മെയ്ഡ് ക്വസ്റ്റ്യൻ. Second point, velocity of the body with respect to a moving platform. With respect to a moving platform in pure rolling. So now we have the condition is like this. The body will be here, but this is connected with a platform. This is a platform, but the thing is like the platform is moving with a velocity called v0. But I told you one condition, okay, to have pure rolling, this condition is a universal condition. You can't change, I can't change, nobody can change. To have a pure rolling, the velocity at the bottom is equal to what? At the bottom is equal to 0. The velocity at the bottom is equal to 0. So let's consider v0 will be here. So let's see, we have vcom. Okay, this is platform, I'm not bothering about, and this is r omega. But I know the velocity of the body with respect to platform is what? 0. അതായത് earlier we have a ground റസ്റ്റിലാണ്, ground is not moving. So what I have done, vcom minus r omega is equal to ground velocity lote I equated. I assumed this is equal to a ground because ground is not moving, my bottom point is also not moving in the previous case. So the velocity of that body with respect to ground is 0 in the previous case. Now I need to have 0 velocity at this point, but it is not with respect to ground, it is with respect to a platform. So that is a relative velocity. Our two velocity would cancel avanam. To cancel that velocity, we should have vcom minus r omega definitely equal to v naught. Previously we have ground, അതുകൊണ്ട് ഗ്രൗണ്ടിൻ്റെ വെലോസിറ്റിക്ക് ഇക്വേറ്റ് ചെയ്തു. Now we have the platform. So ഇതിൻ്റെ നെറ്റ് വെലോസിറ്റി മീൻസ് vco minus r omega, that should be equal to, ഗ്രൗണ്ട് ആണെങ്കിൽ ഗ്രൗണ്ടിൻ്റെ വെലോസിറ്റിക്ക് ഈക്വൽ ആണ്, ഇല്ലെങ്കിൽ if it either else it is equal to the platform velocity, the platform velocityക്ക് ഈക്വൽ ആവണം. Then only what will happen, both are equal means both are get cancel each other. So here we have to find out omega. We are interested to find out omega. Omega is vcom minus v naught divided by r. Important, very much important. Tricky questions will come from this area. Okay, good. Okay, fine. Fine. Okay, so two special cases. One special cases is with respect to ground, another special cases is with respect to the platform. That's the thing. So these two special cases we are defined with the velocity. Can we define the same case with acceleration? Yes, we can do. So we'll do the same case, and that is the fourth one. The third one. The third case, it's the same thing, exactly the same thing, but again the heading I am changing. Third case, velocity of the body with respect to ground, with respect to a ground in. This velocity alla, now this will be changes acceleration of the body with respect to a ground in pure rolling motion, acceleration ground. So let's see, acceleration at the bottom, we have ACOM, we have AT which is equal to R alpha, and you have AC centripetal, and with respect to ground, so I have to say with respect to ground, what we required the net accelerations, is equal to tuck big 0. So what is the ground? We know ground is already at velocity 0, acceleration 0. So ACOM minus R alpha is equal to 0. Alpha is equal to ACOM divided by R. Important. We'll go to the fourth case. So what we'll do, I am altering the heading, but you have to write a new heading. Acceleration of the body with respect to a moving platform. Moving platform in a pure rolling motion. Now the same thing, but what we have extra, we have a box with a velocity called V0. So in this case, what is the formula will changes with respect to the ground, with respect to the platform, a net equal to 0. So with respect to, so total acceleration of the body is this one, and this is equated with the platform acceleration A naught, V naught A naught. So alpha will be equal to ACOM minus A naught divided by R, and this is the value of alpha. Simple once you learn about this one. Okay, this is the horizontal component of the velocities. Okay, but here we know this radial velocity or the centripetal, so the radial acceleration, centripetal accelerations is not 0. Okay, here A net in the sense like I am not considering this AC. Why not consider in the sense of acceleration means with respect to the platform is vertical, so this has no rule with the platform. This platform in the A0 velocity appam adinte forward backward velocity illana acceleration components are important. A vertical component nothing to do for this one, that's what we have not considered the AC. But total acceleration consider the root of our formulas in the previous cases, acceleration at different point. That's where case, this where case. Do not confuse between these two. Okay, hope this is clear. Fine. So let's go to the next topic. Okay, forces in pure rolling motion. Fine. Please write the heading, forces in pure rolling motion. So take out this heading to have some space over here. Forces in pure rolling motion. Let's see what we can do over here. Forces in pure rolling motion. So please write the heading, forces in pure rolling motion. Pure rolling motions forces in the conditions. That's what we are going to do. So forces in pure rolling motion. What are all the forces are acting in a pure rolling motions? Okay, so when the body is rotating, okay, so for example, let me take a body over here. So listen to the board very carefully. Suppose you are giving an external force, just you are just giving a pull. So what will happen? It will just go and started to rotate. And started to rotate at the same time it have a translatory motion, it's moving forward. So whenever it is moving forward, at this backside there is a, because of this force, there is a rotating effects will be there in the backward direction. Correct? Suppose the ball is rotating backward, e side load on a push. This side load will be push. So friction will be in this direction, opposite to the motion. This is very important. Students will have make a mistake over here. Friction will mark in the opposite direction. No, this opposite kana push varunathu, because in order to move forward, correct alle? Once you are going in a boat and you are pulling the water in backward lotu nammal force kodukunu in order to move forward. Appo same way here floor il ee backward force ana kodukunu, so frictions will be in the forward direction. Okay. So and we have a because of this one we have a ACOM, we have a motions will be there in this direction. So what all things we are doing will be here means total force capital F plus small f, total force equal to M into ACOM. This will create as one equation. Similarly, because of this one, this is an equation because of the translatory motion. Because of the translatory motion. Okay, so same case we have a rotational motion also, we have a rotating effects also there. So that rotating effects will give rise to torque. So namukku torque in equations kannam. So force into perpendicular distance, idana idinte perpendicular distance, radius r, idinte perpendicular distance aanu r. So rendu force, so of course rendu torque. Force into perpendicular distance is called the torque. Okay, here you have to remember two things. What are the things I have to say means, here say radius vector is always from the center, always from the center. So you have to remember, okay, you have to see, now you have to see in your front a circle is rotating like this and a force on the topmost point like this. Now there you are going to find the torque direction. Torque means what? R cross F. So R center nanu varunna. So R cross F. F in the direction slow to fold thumb is into the board. This board in the direction because of capital F. You look for bottom also force into a perpendicular distance. So bottommost point R will be in the downward direction. So R cross, okay, R cross F is the direction of frictional force, E direction. So I am folding. So now my thumb is coming towards you. My thumb is coming towards you. Torque will be there because of capital F and torque will be there because of small f. But both torque directions are different. So I am using a sign conventions over here. Whatever is going into the board or into the paper, taken as positive. Magnetic fields into the board we learn in magnetism. So same way, whatever going into the board, into the paper, into the board, everything into the, I am taking as positive. Whatever going in outside, it's taken as negative. You can take in reverse way also, so no problem. Okay, sign conventions you can take it. But torque is a vector quantity, that's what it's important. Topmost point, this is the force and it is R cross F. My thumb is going inside. Bottommost point R cross F in this direction. Thumb is coming towards you. Thumb is coming towards you. So both torques are in the opposite direction. So F into R is into the board. So F into R minus F into R. Both F are different. Okay. Torque. Okay. Total torque will be equal to what called? Total torque will be equal to R alpha. Everything small letter. So put it as R alpha. Equation number 2. This is for what? This is for rotational motion. So rotational motion to torque and equation we have written. One linear motion, one force and equation also we have written. And we also know because of this one, each and every point there is a tangential acceleration. So the value of here, this acceleration value ma value, we can say this is not like a centripetal acceleration, right? This is the acceleration over here. At is the acceleration over here. ACOM is the centripetal acceleration. So because of this force we have At, and At, that's what simply I am writing as A, and A will be equal to R alpha. Equation number 3. These 3 equations you have to remember. Previously I have written ACOM, it's not ACOM, it is AT because this F is giving this AT over here. Okay, so this ACOM has no context here. There's no context over here. Okay. Fine. So A is equal to 80. Forces means we are interested with the forces. Because of the forces we have the motions. Okay. Now if you consider ACOM and AT, if you are considering AT over here, then AT is this big particle. So big particles will give rise to ACOM and big particles will give rise to AC in the inward directions. അപ്പോൾ ACOM മൈനസ് AC ആയിരിക്കും ഈ പോയിന്റിൽ ഉണ്ടാകുന്ന ആക്സിലറേഷൻസ്. ഓക്കെ, യു ഗോട്ട് മൈ പോയിന്റ്. ഹിയർ ഇറ്റ് ഈസ് ACOM ആൻഡ് AC you cannot mark the centripetal accelerations. Correct? Because this is not the ball. ഈ ഒരു ഫുൾ സ്ട്രക്ചർ ആണ് ബോൾ. ഇൻ ദ പ്രീവിയസ് ഡയഗ്രാം ഹൗ ഇറ്റ്സ് ലുക്ക് ലൈക്ക്, ബോൾ വിൽ ബി ഹിയർ, ദിസ് ഈസ് ദ ബോൾ. കാരണം അത് റൊട്ടേറ്റ് ചെയ്യുന്ന സർക്കുലാർ പാത്താണ്, ഓർ ഇറ്റ്സ് എ റൊട്ടേറ്റിംഗ് പാത്ത്. നൗ ദ ബോൾ ഈസ് നോട്ട് ദിസ് വൺ, ദ കംപ്ലീറ്റ് പീസ്, ദിസ് കംപ്ലീറ്റ് വൺ ഈസ് എ ബോൾ, ആൻഡ് ഹിയർ യു ആർ അപ്ലൈയിങ് എ ഫോഴ്സ് ആൻഡ് ദിസ് വിൽ ഗീവ് റൈസ് ടു ആൻ ആക്സിലറേഷൻസ് കോൾഡ് AT. This will give rise to an acceleration, initial accelerations, because it is initially at rest. Rest there is no ACOM. Because of your pull, this A will be get generated. That A is coming, this A is because of this F, not ACOM ആണ് ഈ കേസിൽ വരുന്നത്. Okay, it's not ACOM. എന്നാൽ റസ്റ്റിൽ ഇരിക്കുമ്പോൾ ACOM ഇല്ല. Because of your force only, AT, tangential will generate first. So tangential acceleration is acceleration over here, and this is given by the capital F. Confuse agarde, no need to confuse. Okay, fine. So we have three set of equations. So based on the three set of equations, we will solve the things over will be here. And here torque is equal to I alpha, R alpha and I alpha. Torque is equal to the torque in equation. This actually sum of forces equal to ma ആണ് ഈ ഫോഴ്സ്. ഇത് തന്നെ സം ഓഫ് ടോർക്ക് ഇസ് ഇക്വൽ ടു ഐ ആൽഫ, റൊട്ടേഷണൽ മോഷൻ ഇക്വേഷൻ. ഇത് ഈ ആക്സിലറേഷൻ, ടാൻജൻഷ്യൽ ആക്സിലറേഷൻ്റെ ഇക്വേഷൻസ് ആണ്. ബേസ്ഡ് ഓൺ ദ ക്വസ്റ്റ്യൻസ് വി വിൽ സോൾവ് ദ തിങ്. ഓക്കെ, ഫൈൻ. സോ this is clear. So for all the things we have to write the three set of equations, and it depends upon the positions where you are giving a forces. So let's do a questions over here. Okay. Okay, question is find the value of, find A alpha and frictional force. Question is will be like this: find A alpha and frictional force for the given conditions. For the given conditions. For the given conditions. Condition means it's a ball push ചെയ്യുന്നു F, and we have a frictional force. These two are which is given to you, and F is equal to 10 Newton, and F is equal to 10 Newton, and mass will be equal to 5 kilogram, and radius equal to 1 meter. So what we'll do, we know now we have to create a two set of equations. Total force equal to ma. So capital F plus small f will be equal to ma. Capital F 10 plus F is equal to m 5 ആണ്. So 5, equation number 1. ഇനി ടോർക്കിൻ്റെ ഇക്വേഷൻ എഴുതണം. ഈ ഒരു because of this one you can see R cross F, fingers are inside 10 Newton ആണ്. So 10 പോസിറ്റീവ് 10 ന്യൂട്ടൺ ആണ്. 10 ഇൻറ്റു അതിൻ്റെ റേഡിയസ് അല്ലേ. സോ എഫ് ഇൻറ്റു, okay, we can say F into R minus F into R is equal to I alpha. So F 10 ആണ്. Do not by heart this formula because it has a problem. I will tell you. If you are simply by hearting this formula and go, because the next question is a tricky one. So 10 into radius is 1 meter minus F into radius is 1 meter I. Find the A and alpha of the given conditions. For the given conditions, and here it is like a solid sphere. That is solid sphere on, then only we can use the values over will be here. So I will be equal to, for a solid sphere, 2 by 5 mr square alpha. So this is like 10 minus F is equal to, okay, 2 by 5 M5 R1 square alpha. So 5 gets cancelled. 10 minus F is equal to 2 alpha, equation number 2. Okay, but we know one equations, A is equal to R alpha, alpha is equal to A by R. We can substitute over here. Okay, alpha is equal to A by R, we can substitute over here also. So A by R. Okay, so we'll substitute, and this is our third equations we know, and 3 in we are putting to equation number 2, 3 in equation number 2. So what will come? 10 minus F will be equal to 2 into A by R. R the value is what? 1 ആണ്. R the value 1 ആണ്. So that will get 10 minus F is equal to 2A. This is equation number 4. അപ്പോൾ 4 equation. ഇതാണ് ഇതിൻ്റെ മെത്തേഡ്സ്. 4 equations വന്നു. So equation number 1 we got, equation number 2 we got. ഈ 2 equationsൽ ഈ 3 നല്ല third equation 2ൽ എടുത്തിട്ടു. This already we learned, right? So we got 1 and 4. Always this will come. Now I am doing, now what I am going to do means I am adding 1 with 4. I am adding 1 with 4 because I need to get A alpha R. That's all. A alpha and F. So 1 with 4, 10 and 10 add 20, F add 0, 5A add 7A. So acceleration is equal to 20 by 7 meter per second square. This we can put it in any one of the equation. Acceleration kitti. So alpha is equal to A by R ആണ്. So 20 by 7 divided by 1, 20 by 7 radians per second square. ഇതാണ് ആൽഫയുടെ value. So we got alpha value also. Next what we required, we got F, we got alpha. Sorry, we didn't get F, right? We got A and we got alpha. Now we want to get F. F കിട്ടണമെങ്കിൽ we can substitute any one of the equations. Suppose in equation number 1 I am placing. So let me continue here. ഇതിൻ്റെ continuation ആണ്, ഇതിൻ്റെ balance ആണ്. Equation number 1ൽ substitute ചെയ്യുന്നു. Capital F 10 plus F is equal to 5 into A. A means 20 by 7. So F equal to 5 into 20 means 100 by 7 minus 10. So it is equal to 70 varum. So 30 by 7 Newton. So ഇതാണ് frictional force ന്റെ value, ഇതാണ് acceleration ന്റെ value, ഇതാണ് alpha value. ഈ മൂന്ന് parameters now we calculated it out. So the key point will be writing this equation, writing these equations and writing this equation. Then ഈ equation, ഈ third equation നോക്കി we will place into second. You will get the fourth equation. Solve these equations and you will get the answer for the given questions. That's the key point. Okay, good. Fine. So let's do another question. Okay. Next question is same concept, but yeah, it is bit different. Okay, question will be the same. Find A, alpha and frictional force. Okay, so now the criteria over will be here, means we are applying a force. Listen, center how much distance away? I have to look into my question. It is 10 meters away. 10 meters. Oh, this much length. Okay, 10 meters away. We are applying a forces of 10 Newton. We are applying a forces of 10 Newton. That's all will be given. Now the force is not upward, force is at the bottommost point. So what are the things we have to consider? We have to write out the total force equations. Now we will answer it. We know this body is moving, we are applying a force in this direction and we want to calculate. Okay, so we are saying we are just giving on force. So an omega is marked in the question also. Question is as well. So I'll place it in the red color so that will be much more clear. omega. So what we are going to do means we are going to solve this question. You have to draw a separate diagram. Here we have additionally frictional force will be here. Now we will write a set of equations over will be here. What is the first equation? Capital F plus all this F will be equal to ma, mass into accelerations, mass into accelerations. Okay, so it is just given a kind of a structure, and find a alpha and omega, and find the value of a alpha and f for the ring iota. So for the ring we have the ring. Okay, so now f in the value 10 Newton aanu. So 10 plus f will be equal to ma, equation number 1. Equation number 1. So we don't know the values of the parameters which are given will be there. We substituted or we got the values as like this. So it is equal to ma. This is a equation for a translatory motion. We want to write an equation for rotational motion. So how many torques will be, how many force will be here? 2 forces, 2 torque will be there. So R cross F. So first case force downward aanu. So force downward R cross F 10 Newton. R cross F. Fingers are coming towards you. Towards you is negative. So I am writing minus 10 into center nulla distance. Center nulla distance edukumbodhu how much it will come? Minus 10. That is force act ചെയ്യുന്നത് from the point of rotation ആണ്. From the point of rotation only the forces are, the forces are applying on the point of rotation. So it is how much distance away? From the center it is 10 meters. So force into the perpendicular distance. So R cross F. So thumb is pointing coming towards you out. Adana minus verdukku. So into 10. Okay. So now you got how we got minus 10. Second one parameter I missed in the question. The radius is 20 meters. Okay. So second one is the force direction force side R cross force, frictional force. So thumb is pointing outside. So minus of the frictional force. Let me take the same color. Minus the frictional force into the perpendicular distance means the radius 20 is equal to I alpha. So minus 10 means minus 100 minus 20 F is equal to I mr square alpha. We know A is equal to R alpha, A is equal to R alpha, alpha is equal to A by R. We'll substitute over here and we'll see. Minus 100 minus 20F minus 20F. This is actually our equation number 3. This is actually our equation number 2. Now 3 we are put into 2. So what we'll get? We'll get the fourth equation, sir. Correct? So mr square alpha means A by R. Okay, so mr square. Okay, so minus 100 minus 20F is equal to r cancel mr a varum. R and value radius 20 aanu. So it become 20 times of ma, because 1 r will get cancelled, one r varum balance that 20 ma. Equation number 4. Now what we have to do? We have to find out the values. So either to cancel what I will do means I am multiplying here with the okay, so let me put it like this one. 100 plus 20F is equal to 20 ma minus 20 ma. Okay, so that is a problem, right? Okay, so let's do capital F plus small f which is equal to ma. 10 plus f is equal to ma. We have one equations. And another side 100 plus 20F equal to minus 20 ma. So this F in equal that I can find. So equation number 1 I am multiplying with 20. So what will happen? 20 into 10 is 200 plus 20F is equal to 20 ma. Okay. Now this is my equation number 1 actually I am adding. So this equations I am going to add with this one. What is this one? It is 100 plus 20F is equal to minus 20 MA. If I am adding these two, what should I will get? If I am adding these two, 200 plus 100, 300 plus 40F is equal to 0. Frictional force in a value we got, frictional force will be equal to minus 300 by 40. Minus indicate the direction is against the direction of what you have assumed. That's minus in a value. Minus indicate the direction is not the same as the one you assumed, it is opposite. That's all. You can assume any directions blindly. In rolling motion, this is a standard direction you have learned. You can assume. Now in this case, question is saying no, your assumption is wrong because you got a negative value. So it is in the opposite direction. So what is coming answer? Minus 30 by 4, which is minus 15 by 2 Newton. Minus 15 by 2 Newton. We got minus 15 by 2 Newton. So we got force. Okay. Now what are the things we got? A equal to R alpha alpha we have to find. So first we have to find out acceleration. So F in the value we can place into only one of the equations. So F in the value, F is equal to minus 15 by 2 in equation number 1. Equation number 1. So 10 minus 15 by 2 is equal to MA. MA. M into A. Okay. So 10 minus, so mass has to given, right? Else it's difficult to solve it. Okay. So let's see. So you will get one MA will be here. You will get one MA value from here as well. So definitely the mass has to given, else it's difficult for you to solve it, right? Without mass value, can you solve it? No. Here what will come? 20 minus 15. Then 5 by 2 is equal to MA. No. This 5 by 2 is equal to MA. 5 by 2 is equal to. This will substitute, you will get an MA value. But A is equal to R alpha. Without getting A, you can't find it. So mass has to given. So let's take, we'll include for the question, M will be equal to say 5 kilogram. This will add into the question. M equal to 5 kilogram. So M is equal to 5 kilogram. What will happen? Acceleration is equal to 5 by 2 by M, which is 5 by 2 into 5, which means 0.5 on acceleration. Acceleration 0.5 and then alpha, you know, A by R. So acceleration is 0.5. Radius is 20 meter. Okay. So 10 which multiply, you know, 5 divided by 2 into 10 power minus 2. Correct? This can be written as 5 by 2 into 10 power minus 2, which is 2.5 into 10 power minus 2 radians per second square. 0.5 by 200 ഇവിടെ 10 വെച്ച് മൾട്ടിപ്ലൈ ചെയ്തു, 10 വെച്ച് മൾട്ടിപ്ലൈ ചെയ്തു. സോ 5 ആയി 200 ആയി. 200 100 taken to numerator, 10 power minus 2. 10 power minus 2. So 2.5 into 10 power minus 2. Mass value definitely we required, else we can't solve it. So this I added to the question. This is required. Without that you can't solve the value of the other parameters. It's difficult to do that. Okay. So hope this is clear. We'll move to the last subtopic under the rolling motion. Okay. Let's go ahead. Next topic, as I mentioned, the rolling motion not in an horizontal plane but rolling motion in an inclined plane. So please write the next heading as rolling motion in an inclined plane. Rolling motion in an inclined plane. Rolling motion in an inclined plane. Important on this topic. Rolling motion in an inclined plane. Rolling motion in an inclined plane. Okay. So what happens? Okay. So two cases we will assume. We have a body which can be moved like this one in an inclined plane. In laws of motion we already learned mg sin theta, normal reaction. Okay. If there is no friction, friction is mandatory for a rolling motion. If there is no friction, only slipping motion only slipping or sliding motion, no rotation motion, which means I can say torque equal to 0. Rotation means torque is existing, either no torque is not existing. So this bob ആണ് ഇതിന്റെ സെന്റർ കൂടെ പോകുന്ന ഫോഴ്സ് ആണ്. Why there is no torque? Because mg sin theta is passing through the center. In order to have a rotational motion, we need torque. Torque means r cross f ആണ്. r എന്ന് പറഞ്ഞാൽ സെന്റർ എന്നുള്ള ഡിസ്റ്റൻസ് ആണ്. ഫോഴ്സിലോട്ട് r എന്ന് പറഞ്ഞാൽ സെന്ററിന്ന് ആ സ്ഫിയറിന്റെ സെന്ററിന്ന് ഫോഴ്സിലോട്ടുള്ള ഡിസ്റ്റൻസ്, either up or down. But here force itself passing through the center. mg sin theta passing through the center. So what is the value of r? 0. R is a distance from the center. Force is passing through the center means R equal to 0. Normal reaction is also passing through the center. So what is the value of their perpendicular distance for torque R cross F? F ഉണ്ട്, mg sin theta ഉണ്ട്, plus normal reaction ഉണ്ട്. But what is R cross F? R means what? 0. It's a distance from the center. Both forces are passing through the center means it is torque is 0. No torque exists. No torque exists means only skidding, slipping motions, no rotational motion. But if torque exists, if friction exists, then torque exists. But if friction exists, then torque exists. How? Then torque exists. If friction exists, then torque exists. I am asking you how. Can you tell me? Yes, it's possible, sir. Why? Because frictional force is along this surface, so you have a distance over here. This is called r. So because of this one, F with r, this is what I told, friction is very important for rolling motion. If no friction, you will get a skidding or slipping motions. So you have like this one. So F now you got, right? F you now got. F is over the surface, and with respect to the ball we have a radius r, so we have a torque. But one point we know, this body is moving in a downward with an acceleration a. Now we will write the free body equation and we'll solve this one. This is what is our aim. So listen to the board very carefully. So what we'll write? Free body diagram, sir. Okay, sir. Equations: downward force minus mg sin theta, upward force positive, F is equal to acceleration downward, total force equal to ma minus ma. So throughout multiplying with minus, so I'll get F minus mg sin theta equal to ma. Equation number 1. This is for what? This is for torque. For the rolling motion, this is a contribution from what? Translatory motion on this one. Now next to what we required, we required a rotational motion equation. Rotational motion, we have only one torque. What is that? Force into perpendicular distance. So F into R, which is equal to I alpha. This is my equation number 2. Okay. What is value of acceleration? Acceleration g sin. So Fr will be equal to I alpha. And here I can find the equation for F. F is equal to I alpha by R. What is alpha? Alpha is A by R by R. So you will get IA by R square. F is equal to IR by A square. Now we'll substitute in the first equation. This one I am giving equation number 3. Equation number 3 is put in equation number 1. Equation number 1 will put in. So F is equal to IA by R square minus mg sin theta is equal to ma. A terms everything taken to the common side. So IA by R square. Ma, come on, ma. But if I multiply, throughout I am multiplying with the minus. So F, correct, F, one problem will be here, right? Okay. So throughout I am multiplying with the minus means what should I come? Mg sin theta minus F is equal to ma. Other mistake I made, right? Throughout equation multiply, no? This equation is multiplied with the minus 1. So minus nalla plus nalla minus. So mg sin theta. So the equation I have to alter little bit. So how it come? Now F in badala I am substituting this one. So what should I get? Mg sin theta minus F. F 3 in 1 IA by R square. IA by R square. F in badala. So this is our value of F, then substitute IA by R square is equal to MA. Pakka. A terms one side load edukunu, so mg sin theta is equal to A into m plus I by R square. So acceleration in a rolling motion in an inclined plane is equal to mg sin theta divided by m plus I by R square. M numerator lo denominator lo divide cheyyunu. So what should I get? A is equal to g sin theta divided by m ne divide cheyyappo ivide m is lost, ivide m lost cheyyadu. So 1 plus ivide m will come to the denominator, numerator and denominator m vechittu divide cheyyadu. So this is a very important acceleration of a in an inclined plane for a rolling motion. A is equal to g sin theta divided by 1 plus I by m R square. Important aane, it's very very important. Okay, so we got acceleration formula. This is clear? Okay, so let's move forward. I need to find out a velocity equation also. I need to find out frictional equation also. This is what I am going to do now. Fine. Okay, now we know one translatory motion plus rotational motion will be equal to rolling motions. So we know one translatory motion equation, v square equal to u square plus 2as. S means this distance ആണ്, ഇതാണ് ഇതിൻ്റെ height, ഈ angle theta. So v square means final velocity starting from rest ആണ്, so 0. 2 into acceleration is what? Yes, it's given g sin theta divided by 1 plus I by mr square. Yes means what? If I am taking like a sin theta, you see sin theta is what? Opposite side by hypotenuse. So S will be equal to what? S will be equal to h by sin theta. We'll substitute over, will be here h by sin theta. So what will cancel? Sin theta cancel. So V is equal to root of 2gh whole divided by 1 plus I by mr square. Important relations for velocity. So I got a velocity equation as well, very important. Okay, now we are going to find out the frictional force in the equations of frictional force equation. Frictional force equation, what is the value of frictional force? We have drawn F minus mg sin theta equal to ma. Already we have written, right? F upward, so minus mg sin theta plus f will be equal to, so how we have written, let me take the formula again, free body diagram formula again. F upward, F minus mg sin theta equal to minus ma. So throughout multiplying with this one, so we got mg sin theta minus f is equal to ma. We already got, we want to find out the frictional force. So mg sin theta minus ma is equal to frictional force. So mg sin theta minus m into what is a? A is g sin theta whole divided by 1 plus I by m r square is equal to F frictional force. Mg sin theta is common, right? Both of the things. We'll take it outside. Mg sin theta 1 minus 1 divided by 1 plus I by m r square is equal to F. This is simplified. So mg sin theta into 1 plus I by mr square minus 1. So I by mr square divided by 1 plus I by mr square. Mr square which numerator and denominator also we are multiplying. So what will get? Frictional force will be equal to mg sin theta multiplied with mr square numerator multiply the denominator multiply. So I divided by I plus mr square. This is the value of frictional force. This is the value of the frictional force. But listen very carefully. Listen very carefully. Okay, so I'm clearing this area. All these things should be there on your notebook. No compromise on that. Okay, so let's see. So here friction force which is given mg sin theta divided by I plus I divided by I plus mr square. But you may ask, sir, this is wrong, sir. Why, sir? Because you told, sir, in case of an inclined plane, f is equal to mu n, right? What is n? N equal to mg cos theta. So mu into mg cos theta. Now you told this one. What is the meaning of this one? Important. This is actually called the required friction. I can say this is the required friction to have rolling motion. To have rolling motion. Required to have rolling motion, because this is a minimum value of friction which is required to have a rolling motion. This is the maximum value of the friction offered by the surface. So it's a maximum value of the friction offered by the surface as surface in a roughness, and that is called what? That is called a limiting friction. That is called a limiting friction. Okay, so definitely the limiting frictions FL value definitely greater than the required value. If this condition is met, limiting friction value, definitely this is called limiting frictions FL. This is called a required friction. Required friction is required. Required friction is exist if there is bulk amount of frictions will be there. That is called the limiting friction. So limiting friction should be greater than required frictions to have rolling motion. To have rolling motion, else what happened? Else no rolling motion. That's all. So required friction is mandatory to have this one. So based on this one, we will do one criteria, or we'll do some conditions. What is that conditions? Listen to the board very clearly, very full attention, full pakka concentration, 100% concentration, no compromise. No compromise on this one. Okay, so we know to have rolling motion FL greater than F required, FL greater than FL, limiting friction is what? Mu mg cos theta should be greater than mg sin theta into I divided by I plus mr square. This is a condition for this one. mg cancels. Sin theta na side lo, so mu should be greater than tan theta into I divided by I plus mr square. This is a criteria to have a rolling motion. Criteria to have rolling motion. Idirna mattunda rolling motion illana, no rolling motion, gone. That's all. This is a criteria to have a rolling motion. Okay, next one more key point, energy conservation principle. Next key point on additional point, energy conservation can apply in a rolling motion, in an inclined plane, in an inclined plane. So what we'll do, we will do a problem, we will solve some questions and then we will go ahead. Okay, so please write down a next a question here. Okay, so we'll solve one question and then we will solve it. We'll write a beautiful question, and this is already asked for an IIT JEE main examination. Okay, and the flavors of this one, which means a variety of this one, the same model, same kind, but values are different, same method which is already asked for the entrance examinations of medical stream also. Okay. So this is a question. This is an inclined plane whose height will be equal to 3v square by 4g. A is rolling from bottom to top as shown in figure. Identify the body. For options they have given, of course, A is called a disc, B is called a ring, and C is called a solid sphere, and D is called hollow sphere. So 4 bodies are given. Which of the following is the correct answer for this one? This is what we require to find out. So what we can do, we'll apply energy conservation. Total energy at initial is equal to total energy at final. Most of the cases like this. So initial point will be here. So potential energy initial plus kinetic energy initial equal to potential energy final plus kinetic energy final. What is the potential energy initial? 0. What is the kinetic energy? Rolling, it's happening. Okay, it is undergoing a rolling motion. So it's undergoing, and it is given with a certain velocity, and with the velocity it is undergoing. So half mv square plus half I omega square is equal to, ഇപ്പോൾ അതിങ്ങനെ പോയി ടോപ്പിൽ എത്തുന്ന പോയിന്റ്. സോ സ്റ്റാർട്ടിംഗ് പോയിന്റ് വി ആർ ഗിവിങ് എ വെലോസിറ്റി കോൾഡ് v. അപ്പോൾ ഒരു റോളിംഗ് മോഷൻ വിൽ ബി ഉണ്ടായിരിക്കും. Body is rolling from the bottom position. So potential energy mgh ആണ്. So mg highest point ഇവിടെ വരും. So h will be given 3v square by 4g. So mgh, kinetic energy final no illa, mele പോകുമ്പോൾ velocity 0 at the topmost point. A body is rolling from the bottom to the top and stays at rest as shown in the figure. They have given like a bubble kind of structure, ഒരു dotted like structure മാതിരി also they have given. അത് പോയിട്ട് അവിടെ റെസ്റ്റിൽ നിൽക്കും. Identify the body. That's was question. Okay, so half mv square, which is a kinetic energy over, will be here, and plus half I omega square. So what will do? Half into mv square plus half into I has to find out moment of inertia value. Based on that we can say whether it is okay, whatever it is, whether it is a disc, ring, solid sphere, hollow sphere. Omega means v square by v is equal to r omega. So omega is equal to v square by r square. Pakka. Which is equal to 3 mg v square by 4g. This simplify. That is the criteria over will be here. What is cancel? V square cancel. In 2 on the multiply. My balance steps I am writing over here. So then the balance steps. 2 on the multiply, what will come will be here. M varum ee side la 2 on the multiply plus I varum. I by r square varum. I by r square is equal to 2 on r side multiply nam, left multiply ma, right multiply nam. So avada 6 varum, mg varum, 4g varum. Okay, 4g varum, 4g. So gg cancel ana. So m plus I by r square is equal to 6m by this means 3m by 2. This side load I by r square is equal to 3m by 2 minus m. M by 2. And I is equal to mr square by 2. Mr square by 2 for which body? Mr square by 2, sir, option A, disc. Mr square by 2 disc. Ring mr square, solid sphere 2 by 5 mr square. Hollow sphere 2 by 3 mr square. So this is applicable for a disc. Mr square by 2 is the right answer for the question. Okay, hope this is clear to you. Okay, so question which is based on energy conservations. Okay, most of the type of this question will be based on that idea only.